So we're going to talk a bit more about interaction. Let me know if you have any questions or if you want to pause at any point. So on Monday, we introduced some system variables that tell us things about what's happening in our browser and on the computer that we can use to change our program. And one of the things that helps us do, along with some other things called events, is interact with our work or our program or our art or whatever we're making in P5, and to make it interactive between the user and the project itself. And so that's one of the things that is afforded by computer-based art, digital art, is that we can do these types of interactions that we couldn't do with, a painting or a film or something like that. So that's one of the kind of exciting opportunities that digital art has that other types of work do not. But it also means that we have to learn how to capture those events and also communicate with the user. So we have to do some work in terms of knowing what the user is doing and what their expectations might be based on what feedback they're getting from the program. So in JavaScript, we use events. So events are anything that the user communicates to our device. So with our laptops, that's like typing, anything that they type on the keyboard, anything they click on the mouse. If there's a touch screen, if any touches that they make on your phone, that's also touches or audio input or all these different types of things we can capture with P5 and with JavaScript in general. And if we take a look at the reference for P5, there's actually a section called events right here. And you can see all the different types of events that P5 captures for us. So the device acceleration, so if you have an iPhone or an Android phone, you can measure how fast the phone is rotating, how much it's changing, and the general rotation of the phone. On the keyboard, we can detect for key presses and also see which key is being pressed. And with the mouse, we looked at mouse X and mouse Y and P mouse X, P mouse Y. We also have other things that we can look for, like the mouse buttons, if the mouse is pressed, if we're dragging the mouse, all of these different events that we can use in P5 to see how is the user interacting with our program. So we're just going to start with making a really simple drawing program today, just to demonstrate how we can capture the mouse X and P mouse X, P mouse Y. So I'm actually going to open a different editor. I'm just going to do this one from scratch. And this is just kind of a simple example to show how easy it is to capture this type of data. So we have this canvas, and if we want to know, if we want the user to be able to draw, we can make lines or draw things based on where their mouse position is. So it's really just as simple as drawing a line. So I can draw a line from mouse X and mouse Y. So the current point of the mouse to P mouse X and P mouse Y, so the previous point of the mouse. I'm going to move this over just a little bit. And for this one, actually, I'm going to turn off the background so we can see the history of the line. Oh, sorry, I'll put the background in the setup so we get it once. And so now you can see it's very simple, but I have a little drawing program. I can't really control the stroke or anything like that. But if I wanted to try to draw like a little cat, this is pretty bad. Draw some whiskers. So I can start to detect my user input and create different types of applications, like a drawing application. So we can make this a little bit more complex using mouse pressed. So mouse press is when we click, obviously, with our mouse. And so we can adjust our drawing program. So I'm just going to do something really simple here. I'm just going to redraw the background when I press the mouse. And so this is a new default function in P5. And so there's a bunch of these different types of functions. So when we look at our reference for events, you can see that some of these events are functions like mouse pressed, and some of them are just variables. So they're just a piece of data. And so those are two different ways of handling the information that we're getting from the user. So the functions occur when the event occurs, and we can run some code based on what we want to happen when that event occurs. The variables are just data that changes over time. So the position of the mouse is always changing, and we can use mouse X and mouse Y to capture what that position is. So there's a couple different types of data that we get from these events. So to create a function, I'm just going to use the function keyword, and this one is mouse pressed. And with JavaScript, obviously we have two words, so the second word is going to be capitalized. And all I'm going to do here is draw my background again. So I'm going to cover up what I had in my drawing. So it's kind of like a little eraser. So it's not much more sophisticated, but it's I can do a little bit more with this drawing than I could before. Draw a little apple. And so every time I click, I'm capturing that click, and I'm just redrawing my background. So I'm covering up the history of this drawing. So again, one event occurs at a moment in time, and the other event, the mouse X, is changing, constantly throughout time. Another thing I can do if I want to on here is add some like transparency, just as an example. So I'll only cover up part of my drawing. And if I click more, I'll kind of see that ghosting. So I'm just covering up with transparent layers, so I still see a little bit of that history. So as I mentioned, like setup and draw, mouse press is a function that P5 will call for us if it exists. So it's a little bit different than a function that we would write on our own, which we'll do, I think soon, maybe in a week or two. But we know from looking at the reference that P5 knows about this function and will call the function if we write it. So mouse dragged also detects a button press, but continues executing until the button is released. And key pressed is another function that executes whenever any key is pressed. So it doesn't matter which key it is. Any key that we press will be captured by the key press function. And if we want to determine which key it is, then we can use the key code. So I'm going to add in, well, this is a little bit of a different sketch. Let me just preview this and see what I'm doing. Okay, this is like a slightly different drawing sketch. Okay, so in this sketch, I've completely gotten rid of my function draw and replaced it with the function mouse dragged. And so the mouse dragged will occur whenever I drag the mouse across the screen. So I have function mouse dragged. And for this one, I'm capturing the mouse X and mouse Y and drawing an ellipse where the mouse X and mouse Y is. And I'm doing this thing where I'm changing the size based on that. But what I want to do actually instead of this example is I'm going to base the size on the difference between my P mouse X and P mouse Y. So my variable X is mouse X. I could just use mouse X, but this makes it more clear. My variable Y is mouse Y. And then for my size variable, let's do something a little bit different here. I'm going to say this is, let's say, so this will actually be kind of complicated, but I'll do a simple version first. So let's do P mouse X minus mouse X. And then we're going to make this a little bit more complicated in a second. So what I'm doing is I'm subtracting the current position of the mouse from the previous position of the mouse. So if the previous position of the mouse is greater, the line or the drawing that I'm making will be wider. So I'm going to draw an ellipse here at x, y, and size. And let's see what that looks like. So you can see if I move the mouse faster, my circles get bigger. Let's turn off the stroke so it'll kind of look like a paintbrush. So I'll say no stroke, and I'll do fill as black. So if I'm dragging slowly, the size of my circles is very small. And if I drag the mouse fast, then the size gets larger. But it only works in the x direction because I'm only using x. It also only works if I'm going, well, it works differently if I'm going right versus left. So let's fix that as well. So there's a couple of things I can use here. I'm going to group my p mouse x minus p mouse y, and I'm going to add p mouse x or p mouse y minus p mouse x, so I can get both of those. So now if I do either left or right or up and down, it gets bigger, although it's getting a little too big. So I might want to divide it by something. Oh no, it's doing something weird where it's going. Yeah, so it's going. It's kind of. I'm sure there's a mathematical thing that's doing this, but I'm having a hard time thinking about what it is. It's kind of cool though. Happy accident. But the issue is that I'm not actually calculating how far I've moved because it depends on which direction I'm moving. So there's an easy way to fix that. I can just use the absolute value. So I'll use ABS. That's a function in P5 that gives me the absolute value. And I'll just add that in front of both of my groups. And so now it should be more even, although it's just very large. So let's also divide it by something. I'll divide it by like 10. Anyway, I'm getting a little away from the original idea here, but now we can see I'm getting something a little bit closer. Maybe we'll try dividing it by 6 instead. So now I have this kind of like brush-like effect where the faster I move my mouse, the larger my drawing is. Anyway, that's a little more time than I meant to spend there. So the other thing that I can do with my key press, let's say I want to clear my canvas, but I only want to do it when I press a key, I can use a different function, key pressed. So this is just like mouse pressed, but in this case it happens when I press on the keyboard. So I'll do my background 220. And so it doesn't matter which key I press at this point. Any key I press is going to draw a background and cover up my drawing that I've created. So we haven't quite learned everything that we need to know to determine the key, but we will do that soon. But if we want to know what key it is, we can look at that key code value. So I can say console.log key code, and this will tell me the value of the key. So if I hit space, that value is 32. Let's also look at the key, because that'll tell us the name of the key. There's a few different things. The key code is the number, and we used to only be able to get the number, but now they have the name for it too. So if I hit space, oh, you don't see it because it's space. But if I hit A, you'll see A 65, B is 66. And there's a website where you can look up these key codes. If you go to keycodes.info, it'll show you all the keys. Oh, it's gone. Uh-oh. Maybe that's the wrong address. Keycodes.info. Oh, it's just keycode.info. So if I hit A, you'll see it's 65, enter is 13, space is 32. All of the keys on the keyboard have codes that the computer associates them with. So we think of them as like space or 1 or 2 or 3, whatever. But the computer thinks of them as codes, and then it associates those codes with different keys. I don't know if there's a list of them in the reference. See under key code. So there's some that are built in, like backspace, delete, enter. But yeah, it just actually tells us to go to keycode.info. Okay, so let's look at some more events. So we already looked at how to change the position of the self-portrait when we were using some variables and talking about how to use variables to capture different numbers. And so that's one of the things that we can change interactively is the position of something on the screen. So here's a quick example of that. So you can see I'm mapping the position of my mouse to the position of the circle. So I'm just changing X to mouse X. So that's pretty straightforward because what we're mapping, the position of the X, is mapped to the position of the drawing. But we don't have to only map things, position to position. So I'll just do this preview. You can see my little simpler self-portrait. If I move the X value, you can see the self-portrait moves. And there's a bit of transparency in the background, so you can kind of see where it's been, just to show that it's moving. But we can also change things that aren't directly related to what we're tracking. So we can change things like the color. So if you ever see a color slider, like if you're using Photoshop or something like that, you're moving that slider, but it's changing a value that corresponds to a color. So when we interact with different parts of our software, we're doing things like that. So we can look at this example. So I'm mapping this color to my mouse position. And one thing you'll notice with this is that the canvas is 255 by 255, which is the maximum range of our color value. So that's done on purpose. So let's look at this example, but we'll change the canvas value. Let me just start a new sketch. So all I'm doing here, so I have this ellipse, and let's put it in the middle of our canvas. So I'll do 200, 200, and 200 for the width. So we have an ellipse there, and we're just changing the fill. And so if I have a fill that's like 0, 0, 0, it's just going to be black. And it's not going to change, that those numbers are not going to change. So I could do something very simple, like I could take the red value and put mouse X in there. And now the more I move across the page, the more red value is added into that circle. So when X is 0 over here, the circle is black. And it doesn't really matter where I am on the Y because I'm only using the mouse X. But as I move the mouse across the screen, I add more red to that circle's value. But you'll notice there's a point where it stops changing. And so let's actually draw a line right there. So I'm going to draw a line. So in P5 and in most software, our color values range from 0 to 255 on the red, blue, and green colors. So if I draw a line from 255x, 0y, and 255x height, y, so you'll see a line there. And what you'll notice is the red is changing, and as soon as I hit that line, it stops. It doesn't change anymore. Because there's no value above 255 that P5 understands as a color value. So once we get above 255, it's just maxing out how much color we can actually put in the red. And that'll be true for any of our other values. So if I do mouse Y for green, we're going to see the same thing happen on the y-axis. It's going to get more and more green. And then down here, once we pass 255 on the y, which visually looks different because we're using the vertical axis now, no more color change. So there's a lot of color change up here. Down here, there's no more color change. And so what we want to do, so we're mapping one range of numbers to a different range of numbers that has a different expression. And so if we want that to work a little better, we have to change those two ranges. So that's what we're going to look at doing in a moment. Any questions? Does this make sense? All right, let's keep going. So here we see a canvas that's 600 pixels wide. But now, no matter where I move, if you look at the top left color, no matter where I move my mouse, there's a decent amount of change happening to that color. And that's because instead of just taking the X value from 0 to 600, what I'm doing is I'm mapping that range onto a smaller range. So I'm mapping from the color 0 to 255. So if my X value is 0, my color value is 0. But if my X value is 600, my color value is only 255. And if it's somewhere in the middle, like if it's 300, then my color value is 127, somewhere in the middle, that's gray. And so this is a really useful thing to be able to do to create software where we take some input and then we map it onto some other output. And the math behind this is not super hard, but we don't even have to do that math because there's a function in P5 that'll do it for us. And so let's take a look at that function in our reference. So this is called map, and we can map one range to another. And it's a little tricky to use because there are 5 different values and one optional value as well. So we have to make sure to get those in the right order. Okay, so the value is whatever's changing. So in this case, it's the mouse X. And the first 2 arguments after that are the range that that value is in. So for our mouse X, that value is spatial. It's the left side of the canvas to the right side of the canvas, 0 to the width of the canvas. And then the second 2 values are the range that we want to map that value onto. So for us, it's the color from 0 to 255. And then within bounds is optional, but it's good to use to say true. So if we go below or above that range, it doesn't, the result doesn't go above or below that range. So instead of just using fill mouse X, let's map this value. So I'm going to take out mouse Y for the moment. And so now I'm going to say, let's say R for red is equal to map. And so the first value, again, is the value that's changing. In this case, it's mouse X. And then the range, the first range, is the range that that value is in. So that range is 0 to 400, or if we want to use width for the width of the canvas, we can use that. And then we're mapping it to the range of the color. So it doesn't have to be 0 to 255, but that is our basic color range. So we can say 0 to 255. And then I'm going to replace the mouse X with R. So now you can see the red changes all the way over to 400, whereas before it stopped at this line. So we're still changing that red color value. And let's actually make the canvas black so it'll stand out a little bit more. So we're still, even when we get past this line here, we're still seeing a change in color. So we can take out the line. And as I mentioned, it doesn't have to be 0 to 255. That's just the full value of the color. But we could do something smaller, like I could say from 100 to 200. And so now it'll always be slightly red. The change is more gradual, but we still get that full range of changing color. Another thing is we can flip the range. So we don't actually have to use the same order. So I could say 200 to 0. Now, when my mouse is on the left, it gets darker when I go to the right. So I'm taking out red instead of adding more red. So the map function is really, really useful for mapping different ranges to different expressions. So we'll look at a couple more examples. Any questions before we continue? So another thing we can do is combine these different events to combine our outcome. So right now I'm using red and it's always changing. But what if I wanted to only change red when the user presses the mouse? I can move this code into my mouse press function. But if I have a variable that I'm creating in my mouse press function, remember that it's only going to exist inside the mouse press function. So we're going to have to move R outside of our function. So I'm going to move R up to our global scope. So I'll say let R, or sorry, I should be using variable. Variable R equals, let's just start at 0. And now I can add another function, mouse pressed. And I'll just move this code in here. But now I don't need the declaration. Let is basically the same thing as var, but it's a different style of declaration. But now I don't need the declaration because I'm just changing R. So now it's not going to change just by moving the mouse, but it will change if I click somewhere. So if I click over here, I'll get different values. And I can do that with all my colors. I could make like a random color generator. So let's say I had 3 colors. So I have R equals 0. I have variable G equals 0 for green and B equals 0 for blue. And then I can do the same thing here. So I'm going to go back to 0 to 255. Let's say E is map mouse X 0 to width, and I'll do this one backwards, 255 to 0. And then for B, let's do map it on mouse Y. So mouse Y, 0 to height, and 0 to 255. And then when I fill, I'll do R for red, G for green, B for blue. Okay, so now when I click, I get a random color. It's not random, but it's based on where the mouse position is. But I get these different colors. But it only changes when I click because my code is inside of my mouse press function. So there's a lot of different things you can do with this. This is just one example. For some reason my slides are animating slowly. I'm going to try reloading. There we go. So we can also interact with the size. So we have position, color, we also have size. So again, this one makes a little bit more sense because position and size are both measurements and numbers of pixels, but they're not necessarily in the same place. So you can see the mouse X, if I map that to the size, the value is the same, but they don't have to be in the same place, so they may not look the same. And we can also use a variable and change it based on our mouse press. So I'm just going to throw this into the code that I already have. So let's say I have a variable S for size, and it starts at 10. And I'm just going to increase every time I click. So I'm going to say S plus equals 10. And then I have to remember to put the size variable into the size of my ellipse. So every time I click, my ellipse is growing. I'm adding to that size value just by saying S plus equals 10. Have I talked about plus equals before? We've gone over that. So I can't remember if I've talked about this. Maybe not, because we haven't talked about loops. So this is just a shorthand for saying S equals S plus 10. So I'm adding 10 to S and then reassigning it back to S. And so if I say S equals S plus 10, if S is 10, S plus 10 is 20, and then it goes back to S. So plus equals is just a shorthand for that because it's very common in programming. And when we talk about loops, we'll go over that. So anyway, I can change different stuff. I can change the size, color, position. There's different ways to create interactions. In this one, I'm mapping the mouse position to the size of the canvas. So I'm growing the circle. but I'm doing it backwards. So I'm saying width minus mouse X. So I'm getting the inverse of the position of the mouse. I could do that with the map function as well. So these are kind of like the technical aspects of how to make things interactive, how to take input from P5 and from our browser and map it onto visuals, color, size, and position. But in order to make this interaction meaningful, to look like something, we have to think about how do we have the user interact with something in a way that makes sense. So there's a lot of different ways to do this. We want to map our interaction to something that is useful or is funny or entertaining or interesting, something that the user relates to, because they're not necessarily going to think changing red from, changing from black to red is really that interesting. So for a really simple example, like my self-portrait here, it just maps the mouse to the mouth of the self-portrait. So if I wiggle the mouse around, it makes it look like it's talking. You could do simpler versions of that. Like we could use, let's do it with this one. So I'll turn off this. So I could use, what's my reference? Oh, I went to this page. Mouse pressed. To change the size of the mouth. So I would need a separate variable for that, right? If I say, so right now the size of the mouth is this S2 variable that I have. So if I say function mouse pressed, and I say S2 equals 40 or something like that. Oh, I can't go back. Oh, that's the width. I wanted to change the, let's try S10. The variables that I used for this are not the best. Oh, but that also changes the eyes too. Okay, so that's not necessarily what I want, although that is a pretty funny expression. So if we click, kind of exclaims, but then we have to set it back. But we could do that. We could say function key press. We haven't learned a couple things that make it a lot easier to do more interesting stuff, but we will soon. So I can set 10 back to 10. Or I could, yeah, so I can do different key presses and mouse presses. So that's maybe not the best example, but the idea is that to make the interaction interesting to the user, there has to be something happening that the person understands what's going on. Like moving the mouse will do X. So part of what I want you guys to do for this assignment is also give some instructions to the user, because with this type of interactive art, if I open up this page and I just see this face and it doesn't say like you can click on here or anything like that, I'm not necessarily going to try to get this animation or change if I don't know that it's possible. So there's a couple ways to do this. One is we could actually add it to the HTML. So we could edit the HTML. I could go into this HTML page and go to the body and add in here like a paragraph that says click me, or something simple like that, or click to change my expression. I guess I can also key press on this one. So click the mouse or press a key to change my expression. Something that just prompts the user to know that that's possible. Although we can't see it because of my background. So let's go to the CSS and change the background to white. Okay, so you can put it in the HTML, so it's not part of your sketch, but you can also put it in the sketch. So I could make a text box down here and say click me and put it at width over 2 and maybe like height minus 100. So that's if I want to put it in the bottom. Although I have to reset the stroke and fill real quick to make that legible. Okay, so it just says click me. So you can add your prompts or your instructions into the HTML. I think it looks better that way because then the art is separate from it. But you can also use text to put it directly into the sketch if you want to do it that way. Let me comment this out because it looks kind of bad. So that's the only other requirement for the interactive self-portrait that hasn't been required for the previous projects. So if you look in the self-portrait assignment, so choose part of your self-portrait to animate or use interaction with, and it could be size, position, or color, or a combination of those things. Use the map function at least once. So regardless of what it is, just use the map function at least once in your code, and then add instructions either in the HTML or directly in the P file. So those are the requirements for the self-portrait. And I think we looked at these already at one point, but if you go and look in past student work, this might be a good place to find examples of interactive self-portraits if you're not sure exactly what you want to do. So this is a pretty simple one where Michael, just made this ice cream cone move back and forth, and the alien mouth opens, and you can see that he added the instructions here. So there's some examples. Some of the older ones may not have all of the same components, but there's some examples of different things you could do. And then you can also just think about stuff that you might want to do that's different. It doesn't have to necessarily look like one of these old examples. This is kind of a cool one where the eyes change color based on the position of the mouse, but then if I click, it reveals the rest of the drawing. So yeah, this one I think is due next week. So you have some time to work on this. Today's Wednesday, right? So we have the variable one is due tonight, and then next week you can continue working on this one, but we're also going to start talking about text and images as well. So we'll get into some new stuff. Oh no, we'll talk about it. We'll go over the new project. But yeah, we'll talk about that next week. We can finish up the self-portrait first. Let me stop this recording.